Tony Gervasi from Gates Air Interplex. May the 4th be with you. Only the Catholic people would get that one. Thank you. Here to talk about reliable transport of audio and data over IP. Really, everything's just data. It's ones and zeros. So it's reliable transport of data over IP. Little background about me: 30 years as a broadcast engineer, 18 years as Senior VP of Engineering for Nassau Broadcasting, Senior SV member, Microsoft certified, joined Gates Air in 2018, Sales Manager, Business Development for Interplex. Before that, there's a real brief time that I worked for Ennes for about 2 years. Don't blame me. Before we get started about reliable transport, I really want to touch base about cabling, because in the last couple of months, a lot of the trouble calls I get, like, hey, Tony, I'm having these packet losses, or I take this cable and I have two Interplex boxes right next to each other, and I made this cable and I connected them, and I'm getting packet loss, or I'm seeing jitter, or I'm seeing this, and I'm like, first of all, there's thousands of these units out there, and I can't imagine why you're seeing this on two units back to back. And we started talking, and he was like, oh yeah, I went and bought a Cat 7 cable. Great. What connector are you using with it? Oh yeah, the RJ45 I got from the Home Depot. Dude, that won't work. Well, I made it work. Well, that's the problem. All cables are not created equal. 5E, 6, 6A. There is no such thing as 6E, by the way. It's 6A, and then 7 and 8 and whatnot. But primarily what you find right here is what is 90% of what we're going to be dealing with, or what you'll deal with in any of your plant. 5E is going to be just about 99% of what you have to do for your offices, your office network, VoIP, all the good stuff. 6 is great, 6A is better. 6A is really going to be used for your data centers. Same thing, Cat 7. You can see the speed differences, but mainly in what we're doing for codecs, 5E works great, 6 is fine. Better reject because of the twist. You can see the twist difference and all of that. So I just wanted to make sure we understand the differences in the cable and the connectors, because all is not created equal. You can see the diameter opening of every connector is different, whether you're using a 5E, a 6, a 6A, and then a 7. Notice that on the Cat 7 cable, it's not called an RJ45. It's called a GC45. Though you can find connectors that are mislabeled and buy them on eBay and Amazon and wherever else you're buying cables that say RJ45 for Cat 7 and 8. It's really called a GC45. But make sure you buy the right connector. If you're buying something off the shelf, make sure that the cable and the diameter of the cable, you look at that and you're getting the 5E connector or the 45 connector that is proper. This will cause lots and lots of headaches if you don't. It may work for the longest time, and then a cable gets moved a little bit and all of a sudden it doesn't. And it has to do with the way it's crimped and the little teeth grabbing into the cable. And it may just slide off to the side that it grabbed a little bit, but not a lot. And I'm telling you that I've taken enough service calls of, I can't get this to work because, and then I say, just go get a cable that's pre-made for me, and let's just try that. And all of a sudden, oh wow, look at that, it worked. Ran into a problem in Denver with a friend of mine who was going from a Vistamax to a WheatNet facility, and he sent a shopping list to his IT, corporate IT, of what he needed for backplane stuff and routers and switches and interconnects, and they bought hodgepodge. And we spent a long time building the facility and having a lot of problems with WheatNet and other issues, office networks. With live audio, you're going to notice it a lot faster than you will somebody surfing the internet and buying stuff on Victoria's Secrets, because TCP/IP is going to ask for another packet and just ship it back to you. When you're doing streaming audio, there is no such thing as asking for a packet again. Well, unless you use an SRT. It's just UDP, or it's multicast, is just sending that out. So make sure, this is very important. I just wanted to touch base on that for a few seconds before we move forward. I don't want to get a service call, and I know I won't from anybody in LA, that, hey, I just made this jumper with a Cat 6 cable and I used a Cat 5 connector. Thanks. Oh, and also look at your cable. You will see whether it's a solid core or if it's stranded. Now, most of the stuff that you're going to end up buying, I think in most of the stores, is going to be stranded. But there are some solid core, cheaper 5 cables or 5E cables that are solid. Those are a disaster anyway, so I would just stay away from those no matter what. We're going to review packet loss, media transport protocols, and then methods for reliable IP transport, network security, and we can talk about IP Connect, but that's embedded in something else. OSI model, for all of us who forget this, I like the hints there. Please do not throw sausage pizza away for the OSI stack. Mainly what we're going to be dealing with today is layer 1, the physical layer. That's the hardware itself, the cables, and layer 2 and 3, the data link and the network link. There's your OSI model review. For those of us who forget, what kind of networks are suitable or not suitable for mission-critical networks? Public internet, that's easy. Everybody has it. It's easy to get. It's a lot easier now than what it was even 5 years ago. Private network, safe choice. I know AT&T here in LA you have your virtual WAN, or what's the name that they call it here in LA? They name it something different in every city. But you have that virtual private network they can set up for you, or your private WAN. SD-WANs and MPLSs, the issue with SD-WANs you have to watch out for is that though they will guarantee connectivity, they may not guarantee you bandwidth. So if you're using something with a high amount of bandwidth, moving a bunch of radio stations from point A to point B, one of the backups may be a fractional T or something else they made a sliced out for you on another network. And when it switches over to the SD-WAN, the software-defined WAN, all of a sudden, why am I losing packets and why am I having my audio drop out? And you may find that they switched you over onto a oversubscribed circuit. So be careful with those. MPLSs are great. LTE, 5E, Starlink, or 5G and Starlink. Far better than what they were 5 years ago. I have at my house Comcast, T-Mobile's using their LTE 5G Ultra network, as well as Starlink for testing. And I've got to tell you, the Starlink and the T-Mobile are really reliable options out there for your secondary and tertiary feeds. Security essential regarding network topology, use of VPN. I highly suggest that. And one thing, when you are creating your VPN, make sure you know the tunnel, your MTU, maximum transmission unit, because without that, most devices, just about every codec out there, including ours, defaults at 1500. We can change each one of the WAN ports on a codec to be whatever the tunnel size is, but you don't want to create factionalized packets if you don't have to. And if you have an MTU that's small, and usually with a VPN, your MTU is going to be somewhere around 1438. You don't want to have a 1500 packet and trying to go through down a tunnel that's 1438. So you want to make sure you test for that and you adjust that properly. Turn off services that are not in use. I know this sounds simple, but we all kind of forget it sometimes, or we ramp through stuff. You should be able to turn off. I know on most codecs you can go and do that, whether you're using hardware or software. Go in there and click off and disable what you're not needed on that particular WAN port, and change the default passwords. I know we make you do that, but how many times have we read online a barracks box got hacked because they left the password defaulted, or another box is just change your default passwords. What creates transport problems? And this is with any network, and it's in your house, whether you're streaming at your radio station, TV station. Jitter, best way to describe that is stuttering. Out of order packets, that's going to happen to the layer 3. That's usually a router issue. A router oversubscribed a switch that is working too hard. Network failure, backhoe outage, whatever you want to call it. And then loss of packets, whether it's packet loss in the burst or randomized packets. You can do a priority of service, which would help, but in some instances, and I know AT&T has a problem with this, if you try to do a high priority on packets, their switches don't like that for some reason, and you can actually make your situation worse. I usually tell people in the IPLs, leave them at medium. Let's find a solution other than trying to shove a high priority packet. Now, if it's inside your private VPN or inside your private network, you can do it anything you want. Jitter, again, variations arrival time of packet caused by queuing in the network nodes. Stuttering is the best way to describe it. You can use using either a dynamically sized jitter control or adding a buffer, a fixed buffer size to compensate. Link fades, route change, congestions. Biggest problem I see is when people use like a Comcast or a Cox or something like that, and they happen to be in a residential neighborhood. This happened to a broadcaster whose offices are based here in LA, but their transmitter's in Miami, and he was trying to feed multiple streams down, and every day at 4 o'clock in Miami, he was getting packet loss and dropouts and whatnot. And I said, well, you're oversubscribed. You're on an oversubscribed circuit. No, we're not. No, we're not. And called Comcast 1,000 times. And Comcast is not going to admit, your cable company is not going to admit they gave you an oversubscribed circuit. Come to find out, he was on a circuit that was 168%. And it took a local guy to come in and go, oh yeah, every day at 4 o'clock when all the kids come home and boot up their Xbox and PlayStations and all that, and just knock down the network into nothing. And then we worked around it, obviously. TCP/IP. This is great for, again, watching videos or doing shopping or surfing the net or looking at all your stuff on all your apps. Horrible for real-time transport. Primarily because it throttles down. It will, if it starts seeing packet issues, it will start throttling itself down. That's why you get lagging until it finds a good spot to work, and then it'll sit there. Well, you can't do that with real-time transport. Doing so would just create havoc for your streams. So that's why we use real-time transport over UDP. The best way to describe RTP over UDP or UDP is I'm Maria shouting on top of the mountain, the hills are alive with the sound of music, and you're down below listening. And if you add FEC to that, FEC is the echo. So you may not hear exactly what I said the first time, but you may hear the echo coming off, and that's going to be, oh, well, that's your forward error control or correction in there, where we're sending more information. But FEC is a double-edged sword, because while, yeah, it's great to be able to put 25% or 60% or 50%, you just added that much more payload to your circuit. So if you're on a circuit that's starting to have issues because of third party or an equipment failure or whatnot, and you're running uncompressed linear audio at 44.1, which is 1.5 megabits per second, with 25% FEC, and you go, well, I'm going to add more FEC, I'm going to add 100%. Well, now you just made that 1.5 meg 3 meg, 3.2 meg. And if you're on an oversubscribed circuit, you just shut down your system. You made it even worse. So what I tell people is FEC is use it gently. I suggest 25%, usually no more. And if you're starting to see where your buffer and your FEC is not keeping up, switch your algorithm. Try to, instead of increasing your bandwidth, try cutting your bandwidth. So if you're using uncompressed linear audio, try using Opus at 192. And all of a sudden, if you see your problems clear up real fast, then you know that you have an oversubscription rate or you have a circuit that is failing somewhere. And it also could be something in your plant. It could be a switch. Remember, switches have lanes and highways and how much data they can move at any given time. And if something happens in one of that switch, or somebody plugs something in the network and starts overtasking a switch or a router, that will cause all kinds of jitter and buffer issues also. So it's not just one item that can cause it, it's many little items that can cause issues in your network. Most commonly used for RTP over UDP is the most commonly used for all broadcasters and for all codecs, if you would. Works in one direction, so we can put it on our 950 STL with no problem. I don't need to talk back. I'm just going to shout, and you're going to hear it, and that's great. Works great if you're using it either as a point-to-point or one-to-one, if you're using it as a subnet broadcast, or if you're using it as a multicast. Subnet broadcasts I love to do, especially if you're trying to feed the same information to multiple transmitters or multiple exciters. I could just send everything out to 255, and everything on that network is going to be able to hear it at that point. The disadvantages is no retransmission of lost packets. Your recovery methods are going to be adding buffer, adding your FEC to that. SRT, Secure Reliable Transport. This is something I believe that is unique to Gates Air Interplex right now. SRT is really designed for the video world, and we're part of the alliance, and we took advantage of it pretty quickly. It's still UDP in its nature, but it's bi-directional UDP. So it's an open source protocol, transport protocol. It's, again, similar to TCP/IP. It does it at the application layer, and it uses UDP. It retransmits lost packets. So it gives us the information that we received the packet and has the ability to ask for a lost packet to be returned. And it does it with low latency. Because we're not relying on that handshake back and forth like TCP/IP, like, I sent you a packet, did you get it? Yes, I got it, send me the next one, okay. Here we're just shouting, and you're saying, I didn't get that one, send it again, and we'll just slipstream it out. So again, it uses RTP over UDP, but it's using it as bidirectional or 2 UDP paths. FEC, again, this is that forward error correction. It's very effective in randomized lost packets as long as you have your buffer control set properly. If you're sending 25% FEC and you know that you're looking at your packet size, and let's say if it's an uncompressed linear packet, each packet is 808 bytes, just happen to remember that, you want to make sure that you have enough buffer set up to compensate for the FEC that you're using. If you don't have enough buffer set up, all you're doing is sending an additional payload, and all we're going to do is throw it away because we have no place to put it. So we need to look at the total buffer size as well as what is the total payload size. Remember, the payload size for us is also may not be just be audio, but it could be any of the data that we associate with the audio. It may be your E2X data, it could be RDS, it could be any other information that we want to embed as part of the main audio. So we look at that total packet size, not just the audio packets, and then we'll add the FEC to that. Stream splicing, this is unique to us, to Gates Air. We have, I think, 5 or 6 patents on dynamic stream splicing. Unlike FEC, where it's just sending out 25 or 30% or more of the information, we're actually going to send 2 streams out, 2 separate network paths, and receive it on the receive device in 2 separate network ports. But we'll aggregate the data on the output. So instead of having either or, it's and. And if the duplicate packet's not needed, it just gets tossed. But what we also can do is combine FEC to dynamic stream splicing, and dynamic stream splicing is not only path diversity, it could also be time diversity. So we can actually send 3 streams out, 2 over 2 different paths, and on one of those streams, there's going to be a time delay additional stream to that. Like we add 200 or 300 milliseconds. For instance, I got a station in South Carolina. Today, he's got 3 AM translators all hanging on the end of these DSL circuits that he has very poor service on, and he had dropouts. We activated dynamic stream splicing, and he has 3 streams leaving his studio for each site. 1 in real time, 1 200 milliseconds out, 1 600 milliseconds out. The receive unit knows that these 3 are coming in because of the way we have the header written, and waits for all the packets to come in and reassembles the output as a clean hitless output. So he doesn't have any failures. And if all 3 packets arrive, it just throws the packets it doesn't need away. It dynamically adjusts the buffer based on the longest latency of any of the 3 paths. Well, we know one of them we've already delayed out 600 milliseconds, so we know we're going to have to add at least that much buffer on the receive unit plus whatever the latency is of the path. Here we're looking at the multiple networks for packet loss protection. If we're talking about dynamic stream splicing, taking the 2 separate paths out and adding, as you see on stream 2 at the very top, adding the time delay on that. Again, it gives you hitless operation. By the way, any information that we're sending through here, again, the data embedded on top of the audio through IP Connect rides this path. So that means you can send your E2X data in with your audio, and once you marry them at the studio, it stays married to the output. We don't have to worry about shifting of time. Right now, we have people that are using the old legacy interplex boxes, the racks, the shelves, if you would, and it's a T1 card, and you're feeding audio down to your transmitter site, and you have the WAN card in there, and the WAN card has your E2X data. Well, that's taking the same physical layer, but it may not be taking the same, it's not taking the same network layer because of the way IP packets are going to work. It's going to start shifting things around. So you could see if you watch a Justin or you watch on an FMXI, watch the time diversity, you'll see it shift a little bit. Here, once we marry it at the studio and marry that E to X data to the composite or to the analog audio, it stays married. So we don't have to worry about anything time adjusting again. The only time it'll have to adjust is if something happens to your network, if you switch paths, or you do a software update and Xperi does a code change. Thank you, Xperi. For instance, I just finished doing a project for a station whose studios are in Seattle and the transmitter is in San Francisco. He's running composite, uncompressed linear composite with RDS and HD data, his E2X data, from Seattle to Sutro over our IP links, and he doesn't have to worry about the HD time delay shifting. It's locked and it stays locked, and it's been on the air now since March 14th, I think was their launch date. So it works really well. Here we're looking at the SRT for packet loss protection. Again, running the two paths, but having the ability to look for the retransmission of packets. SRT is great. It's designed around the video world. So it was meant to do video 20% packet loss and still give you clean quality video output. Here we're doing it in the audio world, which is 1/10 of what we would do anything in video. Again, but you need a bidirectional UDP for this, or TCP/IP, but it runs as bidirectional UDP. So this would not work in a situation where if you're feeding it over a 950 link or a one-way link like cellular and whatnot. SRT also initiates the stream from the receive unit. And the reason why it does that is it's going to talk to the far end, and if it has multiple NATs to transport, like if you're running across a Starlink or any LTE network or a 5G network, you're going to NAT 3 or 4 or 5 times. So this will actually be able to punch holes through and keep that path open. So SRT is great for that tertiary or secondary stream that you're going to have to use for your transmitter site if it's over satellite or over cellular. Again, it starts the command, it starts the request the stream from the receive unit, punches holes through all the NATs, keeps the path open, and starts sending the streams through. Main and backup networks. This is something that a lot of stations are doing, and I'm working with Cox on a pretty big system with this, is not only using an IPL unit to an IPL unit through the transmitter site, but also sending it up to a CDN and letting the CDN be able to also send out to multiple sites. This now gives them another layer where, in the case of South Florida, where they have Jacksonville and they have Tampa and Orlando, where we have things called hurricanes, and they got to get out, they can originate all their radio stations from Atlanta then, and operate all of their South Florida stations from Atlanta facility. In reality, they can operate it from anywhere, because once you have a codec at that site, I could be sitting here and run the stations if I wanted to. Using the CDN gives them another ability where they can feed the CDN from any facility and then send it out to any of the transmitter sites or studios. LTE cellular backup, again, that's another source we were just talking about. Whether you're using SRT as the protocol or you're using, we have something called a dynamic initiator. There is, I believe, Comrex and Telos and even Tyline have a, what do they call it? They can transport across. They don't talk to actually the codecs. They have the server up in the network that actually talks to the codecs. That's how you can launch networks down or launch connections between multiple codecs. Transversal servers. Right. That transversal server goes down, your stream goes down, because that is your intermediary box, and they have gone down before. Not blaming Comrex in any way, shape, or form. It happens. It's a server up in the network world. Things happen. We didn't want to be responsible for that. We didn't want to have a server up there and like, oh, well, our server went down. That means your stream went down. So we actually have something called Dynamic Initiator. It does the same thing, except we're doing it between the IPL units. We have the receive unit at the IPL. We set the configuration up there of what we want the send unit to do. And we tell the receive unit, go talk to the send unit, give it its instruction set, which means build the stream, what WAN is it on, what audio path are you using, what codec you're using, what buffer do you want, what sample rate, all the configurations of the stream we can build from the receive unit. And then we basically punch holes through the net and send it out. So it allows the receive unit to use it as a backup, again, whether you're using cellular, LTE, or any other satellite. But we're doing that inside the IPL unit, so we don't rely on us having a server in the upper, in the cloud somewhere. We felt that was a safer method than having to someone, hey guys, anyone do an update on that server? NPR. If you listen, well, there's some NPR people here. You're listening to NPR, you're listening to audio through an Interplex box. Whether it's NPR running Ascent servers between Minnesota and Washington to back up all their audio, their live wire audio between those two locations, or using IPL 200 units for the affiliates and the participating content affiliates that send information down to NPR in Washington, which go through multiple ISPs, just like you see this setup here. It's running through an IPL box. We're just about, I'm thinking about 200 IPL 200s in Washington. Doug bought a lot of them. Because it's not only for what they're using for their internal network, but if you're using the NPR satellite services for your own personal stations, you're also riding on an IPL unit. And uses their backup, yep. Network security, common links, common hacking, misconfiguration systems, denial of service, wrong content on the air. We kind of do enough protection. We'd have a lot of protection really in the IPL units because Interplex's business really was designed around federal government. I was explaining to someone today, my job, 50% of my job is really with the feds. We do the secure communications for the FAA, the FBI, New York City, Fire Life Safety, we're the Southern California Office of Emergency Management, the Highway Patrol here. Thank you. Yeah, you do the California Highway Patrol, the Port Authority in New York, New Jersey. Basically, I'm busy with a lot of fire life safety, government, transport, and two-way work with them. And all the hardware, all the software, all the security we had to build in for that, we translate right into the broadcast world. So when two IPLs talk to each other, we actually create a little tunnel. It's a secure tunnel, allows the units to see what's going on. We have some protection built in where if someone tries to give you denial of service, we'll block that IP address. If someone tries to get in and hack into the system, we'll turn off the web pages so they can't get in and hack it or try to get to the password. So there's a lot of little things that we do that may seem annoying, but you'll never hear of an IPL box getting broken into. We do support SSL, SNMP, where the newest feature is we're going to allow you to install your own secure key if you want to. If you use SRT, you can use AES 256 encryption and AES 512 encryption. If your stream is that important, we can actually encrypt your stream within SRT. We talked about IP Connect, and this is basically how we embed information on top of a stream, an audio stream, whether it be composite, micro MPX, audio, whether it's AES3, AES67. We can ingest all of that, but this is how we embed data on top of it and how we marry that data. And that data is not only UDP data, but it could also be contact closures, it could be RS-232, and we can embed it on top of that. So by doing so, that affords all those auxiliary streams to ride in the same path that your main audio stream is, so that you have all the advantages of using dynamic stream splicing or SRT and all the good stuff. Again, we encapsulate all the local IP traffic. We can bridge across WANs. We're agnostic to what we transport. We're just a pipe. And we have a box that is just IP Connect, so you have your own codec that you like to use, or we have Ron, do you remember the TV station that's in Cleveland, or is it Cincinnati, that's using it? It's Family Broadcaster. Do you remember who it is? It's Paul's customer. We have a customer, it's a TV station that's using basically SRT and dynamic stream splicing combined to feed ATSC 3.0 from his master control to 2 different transmitter sites. And this is all across the public network. He's running it across 2 cable modems out of the master control to 2 cable modems at each one of the transmitter sites. And so he's running 55.5 meg streams with no problem. They're really happy with it, and it's we're pretty proud of that because we got it to work, and we were like, hey, look at that. It's rock solid. We see all the errors coming in, but with SRT, it didn't matter. It just, between the dynamic stream splicing and SRT, it's just doing everything it's supposed to be doing. And again, IP Connect allows you to replicate and translate, allows us to bring information in, send it out to one site or many sites, it doesn't matter. And again, we can use it through multicast or unicast. Our different boxes, the 100C is the compact unit, which I know a lot of you have in here. The 100E goes inside the exciter. The Ascent is our high density product. It'll do 24 live wire, 24 live wire, 24 WheatNet, or AES67, or analog audio if you want. Again, we are the transport mechanism with that. We'll ingest it and then send it out however you want, and we can use whatever codec, because we come loaded with all the AACs, Opus, Linear, MPEGs, IceCast, Shoutcast, so we can send it up, and we can send it up to be your content delivery, to your content delivery network. And then the 100E goes inside the exciter. That's basically, they're fully functional. Everything that you would see in a regular rack unit box, just in different forms. The 100N is the new codec that we showed out at the show. This is unique because it's built on what I call our Ascent platform. We're getting to these boxes now because we've been doing this for so long that this box is going to be universal. This one box can not only do analog audio, AES67, AES3, AES192, micro MPX. We also have an audio processor built in. In no way, shape, or form is it meant to compete with anything of this quality here. It is meant to be your tertiary, your backup processor. So where if you needed to send raw audio to this, you can. It's a 10-band, 10-band processor. Pretty powerful little thing, dirt cheap for what it is. But it's meant to send raw audio to it, and we can do a processed FM into it out to your transmitter site. Point to multi-point has all the flavors that you want. We have our own network monitoring tool where an app or a web page, I can monitor all your streams. And we can tell you just by pulling up the app, if it's a green dot, you know all your streams are okay. We can monitor through dead air, stream failure, IP loss, all the good stuff. As well as we are now doing ad insertion and overplay for top-of-the-hour ID satellite stuff. That is moving very fast. The ad insertion, I'm sending out demos of that right now to particular people. But the idea would be that we could put this out at the transmitter site. It will hang on your network if you have a network out there and mimic either a Zeta voice track box, a wide orbit, and it'll connect to Friendship as part of wide orbit, or it'll connect to, not Zeta, the other one. What's RCS's other software? Not Zeta. Yeah, the other one, the legacy one. Next Gen. It'll connect to Next Gen as a voice track box. And what it'll do is you can trickle down audio to it. It'll read the live log. And if you have all your failures, you can select the internal hard drive and it'll play your audio out. So that is live now. It's been in beta right now for about 60 days. We introduced it out at the show, and we expect to be able to ship that feature by the end of the year, maybe even sooner. But We're also going to look at developing or we'll be shipping out hopefully by the end of the year, a 4-channel version of this, IPL 400, since now we have this new platform. So those are some of the things that we're doing that's slightly different than everybody else. By the way, this is not bashing any of the products. Timeline makes a great box. Comrex, I know when I was at Nassau for 20 years, I bought enough Comrex boxes to choke a horse. They make great boxes. This is just a different level. I'm not expecting these to go out as portable units. Matter of fact, I'm not expecting anybody to ship anything out as portable units. When you have your cell phone, and you can download an Opus app for, I think, $4 and be able to call into one of these boxes or anything else and get full stereo quality out of that. So everybody makes these great codecs. Barracks, we'll talk about that later. If you buy a Barracks box, come on, you know what you're getting. But this just takes us to a different level with security, with the network ports that we offer, with all the security we offer, as well as the features that we're putting in. It's just adding a different layer. So any questions for me?
I have one question. So for SRT, because I've used that over video.
Yep.
Dynamic stream splicing versus your transmitters for over the air.
Yep.
It's like a ATSC1. I think it's SMPTE 2022-7
Yep.
that they support.
Yep.
Would you say that if you were to like set up a network from scratch, if you were to go to one, as in like a transmitter that does SMPTE 2022-7, as opposed to dynamic stream splicing for video?
Totally different.
Okay.
The advantage that we're going to give you over that protocol is we're going to talk an ascent to an ascent. And this would be done, and we're doing this currently for ATSC1, ATSC30. The ascent is basically the box that we use to transport video. And we're doing this for multiple TV stations already, whether they're doing ATSC1 at 19.2 or they're doing ATSC30 at 55.5 meg. It gives the dynamic stream splicing just adds another layer of protection to what that protocol is. So we're gonna. I have a lot of people who like a TriCaster software that has SRT built in, but they're still having packet issues or having loss. And we're basically, the Ascent allows us to clean that up. So we're, again, agnostic to what you're feeding us. We're just going to act as that tunnel between the two and clean up anything that needs to be cleaned up using what we've built in. So we've tested a bunch of different codecs with the Ascent because we don't have a video codec built into it. We didn't want to. Everybody has their own selection, especially with ATSC30. There's a lot of different options there. But we've tested it where we can go ahead and just ingest that information and send it out, and using the protocols that we have and all the features we have, clean up any transport issues. Yeah. So it just adds a layer of protection to that.
Anybody else?
Can we get the slide presentation?
No, you cannot have this.
Oh, come on.
I can send it to you, or I believe the chapter will have, or chapter should have a copy. If not,
Yeah, I'd like to.
Another quick question. I came from an environment where they're using Jumbo Frame 9000.
Yep.
This works fine with it, right?
Yep.
Okay.
Yep. Again, we just have to go in and tell it. By the way, the Ascent is for us, it's a hardware and a software. For radio, we're making a hardware software solution. For like Stream Guys, who's our partner for CDN, it's just a software solution. We sold them the software package. We gave them the specs of what we wanted their server to be to minimum, and they've put it on there. Cox is the same way. Cox bought the software package. We told them what hardware to get. So it is a software solution, just as long as you meet our minimum requirements. The one thing that we do kind of tell you that you're going to buy with it is going to be a software assurance for 3 years. And basically what that does is just gives you the ability to get all the major upgrades, which we're doing at least 2 a year. And after 3 years, if you don't renew it, it doesn't matter. It's still going to work. There's nothing that's going to turn off on it. And we don't limit this box. There's competitors of ours in the TV world that limit their box. Oh, we're going to allow you to do 4 streams and pay this much money. Run as many streams as you want. In the audio world, we have people running 200 streams on this. We don't care. In the video world, I think the most we've run through it is 600 megabits at one point. So the limitations really that is going to be what your NOC is and what your data pipe leaving the building is. We're not going to limit you on what it can send and what it can receive.
So Tony, in all seriousness, where can they get a copy of this?
Yeah,
You can send it to us, I'll give you our email address and I can distribute it.
yeah, that's fine.
Is that good? Okay.
I think I have USB sticks with me, so I can also go to my laptop and just make a quick copy.
Sure,
Like
yeah.
right now. Any other questions, comments, inquiries, complaints? That's a good presentation.
Yeah.
Thank you, guys.